In this lesson, we shall focus on Mathematics 1B, Math 141, Tutorial 9 of the 30th of September up to the 4th of October, 2024, Parametric Curves. Find the equation of the tangent line to the curve x equals e to the power t, y equals e to the power minus t, at t equals 1. First, in part A, we shall do this without eliminating the parameter. Without eliminating the parameter. Without eliminating the parameter. So, right now, you'd actually be aware that at this point, we have the following. In part A, we have x, which equals e to the power t. Simultaneously, we have y equals e to the minus t. And these happen at x equals 1. What do we do here? To find the equation of the tangent line, you need to find the slope of the tangent line. So we need to find dx dt. And dx dt is e to the power t. dy dt is minus e to the minus t. And which implies that dy dx is dy dt dt dx. dy dt is minus e to the minus t. Minus e to the minus t. And dt dx 1 over this. And this equals minus 1 because or e to the minus 2 negative. So this is therefore going to be the same as negative e to the minus 2t. This way. So now this is the chain rule here that allows us to then say the dt cancels. You can imagine it as sort of canceling, although that's not possibly the correct way to look at things, but you can imagine cancellation. And then when cancellation happens, we're able to get the result. But let us see what we do next. So we then have to then say, we then have the following to do. We then have the following to do, like when you have this here, then what is the slope? Right, so we actually can be able to find the y dx at t equals 1. Right, at t equals 1. Which is minus e to the minus 2t at t equals 1, which is minus e to, substitute the t by 1, and you get actually minus e to the minus 2, like this. Right, after this, you can divide the board a little bit. And then use y minus y1 is mx minus x1, or if you don't want to use this, you can use y equals mx plus c, or other alternative methods. Now, at t equals 1, x is e to the t, which is e, and y is e to the minus t, which is e to the minus 1. So you have e together with e to the minus 1, which means with y minus e to the minus 1, the slope is this, but you need to evaluate, obviously, the slope at t to e equals 1, which is this one here, minus e to the minus 2, x minus x1, which is exactly, so this is x1, y1, the x1 is e. This is minus, this is exactly minus. This is minus e to the minus 2x. And then, of course, if you multiply out here, it's going to be plus e to the minus 1. Yeah, plus e to the minus 1. Minus 2x plus 2e to the minus 1. And therefore, that would be the answer. And this is the answer in the case that we are then saying we are not eliminating the parameter t, and therefore the answer becomes the one we have just obtained. So pay particular attention to the answer we have got. This one here. This one there. That is the answer we have got. In this answer that you've just got is very, very important to us. And we'll move on to the next question. Right, so this, but it is, we still now look at part B by eliminating the parameter. So now if x is e to the t is e to the minus t, then we need to eliminate the parameter t. Right, to eliminate the parameter t, the couple of things that we need to do so that we are dealing with an equation at t equals 1 by actually dealing with only x and y, but such that t is eliminated. And this would mean here would have ln x is t, and obviously, I mean, this comes with taking the ln both sides. All right. So ln x, t ln e, ln y minus t ln e, which is t minus t, which means that ln y is minus t, but t is ln x. So this means ln y is ln x to the minus 1. Right, so you'd have that. Okay, so um this becomes the equation of a rectangular hyperbola. Right, it becomes the equation of a rectangular hyperbola. But now pay attention. We need to then have the following. So you then take into account a couple of things. What exactly then do we do here? We'll then be in a position to analyze these. Analyze these. Right. Let us analyze these. Okay. So this rectangular parabola presents something in the sense of it being this y is 1 over x, but 1 over x is x to the power minus 1. The dy dx is minus x to the minus 2. Okay, minus x to the minus 2. So if this is the case, dy dx would be at t equals something. What would x be? Like at t equals 1, x is e to the power t, which means that x is e. Okay, so this means that at t equals 1, x is e. So, so now we have this. Okay, so that becomes the slope, which is the same as what we got before. Just in the part A. So simultaneously at t equals 1, x is e to the power t, which is e to the power 1, which is e. Y is e to the minus t, which is e to the minus 1. Which means you have y minus y1 is mx minus x1. Obviously, at this point, it is through the point. Okay. It is through these points. So the point suggested by these is the point E that. So this passes through the line, would therefore pass through E minus 1, giving us x1, y1. Y minus y1, which is E minus 1. The slope is this one here, e to the minus 2, and then x minus x1. Which is minus e. Which is minus. So this one plus e to the minus 1 plus e to the minus 1. When transpose this one, it becomes plus e to the minus 1, giving us y equals minus e to the minus 2x plus 2e to the minus 1. So this becomes the answer. But obviously, I mean, if you remember very well, we have got this answer before. 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 Right. So that is what we have. That is exactly what we have. Right. Right, 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 right. So we continue. Right. Okay. So we've done this. So obviously, I mean, the aim is to get some questions done, but it's not, doesn't mean we need to do everything until we can't breathe. So let us move to the number 2, for example. Here is number 2. Determine all values of t at which the curve, this one, x equals this and y equals this, has a horizontal tangent line and has a vertical tangent line. A horizontal tangent line would mean that the following. So, right. Right. Right, 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 right. So we actually look at the 2, so you have x is 2t cubed plus 24t plus 7 plus t plus 1. So which is dx dt. This is 6t squared, 30t plus 24. Okay, we find the derivative of x with respect to t, but we also find the derivative of y with respect to t, and derivative of t squared is 2t, the derivative of t is 1. So now we have got this, but now we need to find the fact that we need to consider the fact that in part A we're doing, there is a horizontal tangent line. What does it mean to say there's a horizontal tangent line? If the tangent is horizontal, then its slope, the slope of the tangent is 0. Now, the slope of the tangent is given for dy dx. But this is dy dt dt dx. What is dy dt? It is 2t plus 1 dt dx. 1 divided by 6t squared plus 24. So we have the following. So if this is horizontal, so you can write it like this, so you can write dy dx is 2t plus 1. You divide by 6t squared minus 30t plus 24. If you then have to then say horizontal tangent, horizontal tangent line. Horizontal tangent line, it means that the tangent line is horizontal, parallel to the x-axis. And if this is the x-axis, then tangent line is sort of parallel to this. Now, if the tangent line is parallel to the x-axis, a couple of things you need to take into account. It is the fact that dy dx itself must become 0. And if this is the case, what is dy dx? It's this, which means you have 2t plus 1, 6t squared, 30t together with 24. The result is 0. You cross multiply, which means 2t plus 1 equals 0. T equals minus 1/2. Right, right, right. So we continue. Right. We continue. We continue. Okay, so indeed, the in A t is what is minus 1/2. So you have that. Indeed, it is exactly minus 1/2. We have exactly that. Right, 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 right. So we're able to see these here. We're able to see these precisely. Now, there are then certain things that we need to take into account. And they already follow. Let's look at the next question. The next question is going to be part B, when we're saying we have a vertical tangent line. Right, so in part B, we take note that x is 2t cubed minus 15t squared plus 24t plus 7. Y equals t squared plus t plus 1. Let us find dx dt. 6t squared minus 30t plus 24. Dy dt. 2t plus 1. Dx dt. D. Y dx. Like we did. So you'd have dy dx by the chain rule. That is dy dt dt dx. Dy dt is 2t plus 1. dtx is 1 over 6t squared, 30t, and 24. So, which is 2t plus 1,
Oh, wow.
6t squared minus 30t plus 24. Now, there's a couple of things we need to take into account. It is the fact that now we are dealing with a vertical tangent line. Right, so when we're dealing with the vertical tangent line, and if it is vertical, it means that the slope, so dy dx would be either plus or minus infinity. And now at this point, it would actually therefore mean that in dy dx, which is 6t squared minus 30t plus 24, this would mean this one equals 0. If indeed we agree that the denominator 6t squared minus 30t together with 24 equals 0, divide by 6, getting this one minus 5t plus 4 equals 0, which is t minus 4 t minus 4 t minus 1 equals 0. And what exactly do we achieve here? T is 4 or T is 1? T is 4 or T is 1, and that is the answer. And that is the answer. So think about this. Okay, obviously, I mean, this is in line with what you call the parametric curves. This is certainly in line with what we call the parametric curves. And we'll take a look at the next question. We'll take a look at the next question. All right, we take a look at the next question. Right. We take a look at the next question. Now, all right. Right. So we continue. We continue. Ugh. Okay. Okay, so this was 2B. Let's move to number 3. Let us move to number 3. So number 3, we have the following. We have the following. Right. So we have exactly the following. Let us check number 3 together. Let us check number 3 together. Okay, here's number 3. Now at this point, okay, I wanted to maybe say something about number 2 here. I wanted to say something about number 2B. And now this becomes a vertical tangent line when the derivative is plus or minus infinity, and that would happen when the denominator of the dy dx expression is identically 0. And this would mean at this point t equals 4 or t equals 1, or obviously at this point you could say by symmetry t equals 1 or t equals 4 at the same time. So move on to the next point. Now, if you look at number 3, find the arc length of the curve over the stated interval. Let us find the arc length of the curve over the stated interval. Now, the arc length is given by the following. Let us do the arc length here over the stated interval there between minus length 2 to 0. So we would have to first look at the fact that we've been given x in the part A. But we can see that x is t. Y is the cosh of t. So at this point, what we would achieve is that our x is clearly t. Let's find the derivative of this. So dx dt is 1. Dy dt is the hyperbolic sine of t. So now we have L is the integral from a to b of the square root of dx dt squared plus dy dt squared dt. That is the arc length. Here you then integrate from the negative the ln of 2 to 0. Dx dt becomes 1 squared. Dy dt becomes the hyperbolic sine squared of t dt. Now, I want to bring to attention something very important, that the cosh squared of t minus the hyperbolic sine squared of t is always 1, but always. So that whenever you have the cosh squared of t, it is 1 plus the hyperbolic sine of t. Which is 1 plus that becomes the cosh squared dt. And therefore, it becomes the integral of minus ln that. The square root of the cosh becomes the square root of the cosh squared becomes the cosh dt. Right, so if you evaluate the integral of this, the integral of the cosh is the positive hyperbolic sign from minus the ln of 2 to 0. This gives us the hyperbolic sign of 0 minus the hyperbolic sign of minus ln 2. Right. So so now you have the hyperbolic sign, but the hyperbolic sign of t is e to the t minus e to the minus t out of 2. In the same way that we need to be aware that the cosh of t is e to the t plus e to the minus t out of 2. So if you are making this 0, it's going to be e to the 0 minus e to the minus 0 out of 2 minus, then you're dealing with the hyperbolic sign, which is e to the minus ln 2 minus e to the ln 2 divided by 2. Right, so what is e to the power 0? It is 1 minus 1 out of 2 minus, what is e to the minus ln 2? Is 1 half minus 2 over 2. 1 minus 1 is 0. And then you have 1 half minus 2, which is minus 3 over 2, which is going to give us exactly 3 out of 4, because it's 3 out of 2 divided by 2, which is 3 out of 4, which is actually the answer we've obtained there. And this gives us the arc length of a parametric curve in part A. The arc length of a parametric curve in part A. Obviously, we need to practice more. And we're going to look at the next question and see what we can do. And see what we can do. Right. And see what we can do. Let us look at part B. Part B. Same thing, so we actually are looking at 3b. X equals 1 minus 5t to the fourth power. Y is 4t to the fifth power minus 1. Dx dt becomes the following. So minus 20t to the third power. Dy dt equals 20t to the fourth power. But L, we know very well, is the integral from a to b of the square root of dx dt squared plus dy dt squared dt. So L therefore becomes the integral from 0 to 1. What is dx dt? So dx dt is minus 20t cubed, and then you square it. The dy dt is 20t to the fourth power, and then you square it. So this is the integral from 0 to 1, and then you have the square root. If you square the 20, it becomes 400. Or you can just write it as 20 squared, right? 400 t to the sixth power plus 400 t to the eighth power dt. So we need to deal with this. So you have the integral from 0 to 1. And then you'd have to factor out 400 t to the sixth power. Inside the under the square root, you'd have 1 plus t squared dt, which is 20t cubed 1 plus t squared dt. Just like that. So the question is, what is the integral of this? What exactly becomes the integral of these? Okay, so it's something you need to think about. Something you need to think about. So this particular integral here becomes exactly the following. So when I ponder on what the integral of this function is, for just a split second, and then we're good. For just a split second, and then we are so good. We are so good. Right, then we are so good. Then we're gonna have the all right, so now then what becomes this integral here? What would you get the integral here? Right. So we ponder on this very carefully and see then what we're able to achieve. Right, so to do this integral, we use the U substitution. So if we agree that the integral is 0 to 1 of 20t cubed, the square root of that. 20t cubed, the square root of 1 plus t squared dt. And we can use the U substitution. And if you use the U substitution, and we decide to to actually let, right, and decide to let. If you let u be actually the same as 1 plus 1 plus t squared, du dt is 2t. So, if this is true, L is 22 cubed, then you have the square root of u. dt is du over 2t. You divide and it's 10. You have t squared u du. This is 10, the integral. What is t squared? From this, t squared is equal to u minus 1. The square root of u du. So we have the following. So, right. Right. So now this becomes 10. The integral of u to the power 3 out of 2. U to the power 1/2 du. So you have, so if you're gonna look at the limits of integration, because t is from 0 to 1, t and then u. All right. All right. Okay. Right, 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 right. Right. Right, 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 right. Um, um, okay. T becomes 0 to 1. Means in u, because if you look at u, is t squared plus 1. So if t is 0, then you have 1. T is 1, then you have 2. So you'd have 10, the u itself. You see here, the t is from 0 to 1, but the u is from 1 to 2. 1 to 2, 1 to 2, 1 to 2. Right. So then you'd have the following. So L is 10. Then you do this, which is, if you add 1, it becomes 5 over 2. So this one becomes 2 out of 5. Then you have u to the power 5 out of 2 minus 2 out of 3, u to the 3 out of 2, 1 out of 2. 10. 2 out of 5, 2 to the power 5 out of 2, 2 out of 3, 2 to the power 3 out of 2, minus. Um, right. So now you then have 10, which means that you'd have 2 out of 5 minus 2 out of 3. Okay? So now we just need to simplify this thing we've got. So you can pull out common factors, etc., and see what we are able to achieve. So let us check what we can achieve here in line with what has been given. Well, the answer is to be 8/3 of 1 plus um um right. Mm. Okay, so right, so we have exactly that there. And then we are moving on to the next thing. Right. So yeah, this is what we have exactly. But what actually is all this? So let us take this and attempt to simplify this and see what we can achieve. So we're going to have, for instance, our L. Try to simplify the things here. We have our L. This is 10, exactly 10. So what we then can do is to extract 2 as a common factor. 2 by 10 would give us exactly 20. At 20, and then you have this, which is 2 to the power 5 out of 2. And 5 out of 2, we've seen that is actually 2/3 plus 1. So which is 2.5 this. 2.5 is the same as what? 2 squared and 2 to the 1/2. So we can write it as 2 squared, and then the square root of 2, you divide by 5. Minus, the 2 has been extracted, to the square root of 2, you divide by 3. And then you have this, 15. Divide this one by 5, you get a 3. 6 minus, divide by 3, you get a 5. By 2 is a 10. What is the arc length of this? So it is 20. And then you're going to have, doesn't matter, you can have exactly 15 in the denominator. Divide 15 by what? By 5, you get 3. 3 by 4, 12. 4. Divide the 15 by 3, you get a 5. 10. So now you have this one, which is 10. The 6 minus 10, which is negative 4, giving us a 40. So now you'd have a 2. Yeah, 12 minus 10 is a 2. The square root of 2 divided by 15. Minus you divide by 5. 3 and 8. Okay. So if you check, what exactly is this? So this is going to become, for instance, the arc length of the curve from this point. 5 goes how many times? 5 goes 3 times into 15, and then 4 times into 20. So in other words, we are saying you can simplify this 3, 4. And this would give us 4 by 2, would give us 8. The square root of 2 out of 3 minus 8 out of 3. 8 is a common factor, giving us 8 out of 3. And then you'd have exactly what? Let's check the numbers. So this is going to be plus. Right, so this is going to exactly be plus, plus. And then you need the square root of 2 plus 1. And this is the answer. But this answer can also be written as 8 out of 3, 1 plus the square root of 2. 1 plus the square root of 2. Okay, so that is the answer. And that becomes answer. But obviously, I mean, we need to understand that this answer here is answer in units. It is surely an answer in units, because it's arc length in principle, as much as it has been given like this, but strictly speaking, you need to say it is not, because it's length, and length is measured in units, be it meters or anything like that. So it is exactly in units. All right. So any question? We're going to take a break right now. We're going to take a break right now, and then we shall actually see what to do next. We can meet again at 4 a.m. and then continue from there. You can also post us with suggestions on what you think we need to do, which parts of the chart we need to do, so that we can tackle those parts. For now, we thank you for joining us. It was awesome having this discussion until 4 in the morning. Thank you so much for joining us. Take care, and Goodbye. Goodbye. Goodbye.